Well, greetings, Mr. Kolazar's class. For video 5 on our acids bases, we're going to look at our hydrogen ions, and what we're going to talk about is Kw. Now, we're going to look at the autoionization or self-ionization of water. We talked about it being self-ionization also of water, and the products of the water ions and their constants. Now, we're also going to look at their calculations today. Now, a couple things that we're going to look at. First off, pure water is neutral. pH, we're going to talk about, is going to be 7 on the pH scale. Now, it's going to contain equal amounts of hydrogen ions and hydroxide ions. Now, as it self-ionizes, water as a liquid is going to break apart into hydrogen ions and hydroxide ions in aqueous solution. And remember, H plus is the same as H3O plus. It's technically the same thing, the hydrogen and hydronium ion. Now, as it dissociates or breaks apart, ionizes into H plus and OH minus, experiments have shown that the H plus concentration equals the OH as that water breaks apart to about 0.0 or 1.0 times 10 to the negative 7th molar, or 3, 4, 5, 6.1 molar concentration. So only a very small amount of the water actually changes and ionizes into the hydrogen and hydroxide ions. Now, this equation, Kw, is from last chapter. KEQ is what we might have heard of it before. This is specifically for water. And our KEQ, remember, is your products over your reactants concentration, and it's based on if there's any coefficients, those numbers would be placed as exponents at the top. So what we're looking at is products over reactants. Now, if you have a liquid or solid, those numbers are going to equal 1. So this equation is really only for aqueous. So our aqueous are what we're actually going to be using. Liquids and solids are going to equal to 1. If we were to take these concentrations at equilibrium, hydrogen concentration times the hydroxide concentration, if we were to put those in, would equal 1.0 times 10 to the negative 14th, and that's our constant number. So as one of these changes, the other one's going to change. So if we increase one, we're going to decrease the other. They're inversely related to one another to solve for our problems. Remember in Châtelier's principle from last chapter, if it's going to always equal, if one goes up, the other one's going to end up going down to keep us balanced out. So if you increase hydrogen or hydroxide, it's going to shift the equilibrium to the left, decreasing the other ion. So like if we add more hydrogen, we're going to shift to the left, but it's going to take more hydroxide to do that, so we're going to end up decreasing the amount of hydroxide in the solution, and as we decrease that amount, it will become more acidic. So our Kw concentration, hydrogen ion times hydroxide ion, equals at 1.00 times 10 to the 14th. That number is constant, so you'll either be given one of these and have to find the other, or you'll be given one and have to find the other. So our first problem is, what is the hydrogen concentration if the hydroxides ions, if there is 0.005 molar hydrogen ions in concentration. Remember, hydrogen ions, the same thing as the hydronium ion. So we have our equation H3O times OH equals 1.0 times 10 to the negative 14th. If we're trying to find hydroxide ions, we'll divide by the OH, or divide by the H3O positive, so that we can cancel that side out. Or divide by the H3O, which happens to be, in this case, 0.005 molar. Now a refresher on our calculators. If we were to take that number, 1.00 times EE key, negative 14, that EE takes care of that, times 10 to the negative, divided by the 0.0050, we end up with, oh, I subtracted. Let's try that one more time. Ten to the negative 14th. Let's use the right key, divided by you get about 2 times 10 to the negative 12th. Molar concentration, showing we have a very small amount of our hydroxide ions in concentration. Now our second problem, what is the concentration of hydronium ions? If there is 4.5 times 10 to the... So concentration of hydronium ions, if there are 4.5 times 10 to the 4th molar hydroxide ions in concentration. So for this problem, what we're going to look at is, if you have known this, trying to find hydronium ions, which would be this part. I'm going to have you solve for the rest of this, and then we will check that answer over in class.